Hello everyone, I am Dr. P. Sudandra Kumar, Assistant Professor, Department of Physics, K.S.Rangasamy College of Technology, Tiruchengood. So, today we are going to discuss about the basics of laser. So, before entering into the topic, we must know what is laser. So, laser stands for light amplification by stimulated emission of radiation. So, the abbreviation of laser is light amplification by stimulated emission of radiation. Here, the stimulated emission is the main phenomena for achieving the laser action. So, it is a device which produces a powerful monochromatic and coherent beam of light. Then, it can travel over a long distance. Then laser can be produced using solids, liquids, gases and semiconductors, etc. These materials are all commonly called as active media in laser. Then the application of laser is various in telecommunication, medicine, biology, computers and military, etc. So then why this laser light is this much importance when compared to the normal ordinary light. So, before that we must know the history of laser. So, laser was first invented by T.H. Mayman in 1960. So, that is the first invention of laser. Before that, in 1953, Charles Hurstons invented maser. Maser stands for microwave amplification by stimulated emission of radiation. So, after the invention of laser, in later days, some of the other types of laser like helium neon laser and semiconductor lasers are invented in the later days. So, the T.H. Mayman first invented the ruby laser. That laser is called ruby laser. So, then there are some of the important characteristics for laser light when compared to the ordinary light. So, they are the laser light is having highly monochromatic nature, then it highly coherence, then high directionality, then the laser light is having high intensity. So, we will discuss it one by one. So, first the laser is highly monochromatic, which means mono means single. So, it consisting of only one wavelength. So, that means the laser radiation is monochromatic and it contains only one particular wavelength of light. Then the wavelength is determined by the amount of energy released. So, in this, then the second most important characteristic is the laser light is having higher amount of coherence. So, which means all the photons will move in a single phase, but in the case of ordinary light, all the photons moves in a different phase. So, in this diagrams we can differentiate with coherent light waves and incoherent light waves. So, here the radiation having single wavelength, same amplitude, same phase and same direction is called coherent radiation. Then the waves are identical in phase and direction. Hence, it produces high power of laser light. So, laser light is having high directionality, which means it travels in only one direction. So, laser emits light in single direction, whereas ordinary light emits in different directions. So, then laser beam of light can travel very long distance without much divergence. Then, so this laser light is having high intensity. Because of its higher directionality and high coherence nature, the laser light is having higher amount of the higher intensity in nature, whereas ordinary light is not having higher intensity. So here the intensity and hence the brightness of the laser radiation is high. Then laser source emits light as a narrow beam. Then the energy is concentrated in a small region, that is small spot. Then, so there are some of the differences between ordinary light and laser light. So they are, ordinary light is less in intensity and it has laser light is high intensity one. So then light emitted is due to spontaneous emission. Here in ordinary light, spontaneous emission is responsible for the light emission, whereas in the case of laser, stimulated emission is the responsible for Then in ordinary light they are not directional, and in laser light the laser light is highly directional. So then the radiations are, here the radiations are polychromatic, but in the case of laser it's a monochromatic. That means it consists of single wavelength. So then it's not a coherent beam. Ordinary lights does not contain a coherent beam, whereas the laser light is a coherent beam. Then the angular spread is more. Here the angular spread is less. Then the example of the ordinary lights so are sunlight, mercury vapor lamp, etc. Then example of lasers are ruby laser, carbon dioxide laser, etc. So then, so the interaction of light radiation with materials. So the interaction takes place in three ways. They are absorption, spontaneous emission, and stimulated emission. We will see it one by one. So first one is stimulated absorption. That means when the photon of energy h nu incident on the atom in the ground state takes up the sum of the energy and moves towards the higher excited state. So this process is called absorption, that is stimulated absorption. So then, so the next one is spontaneous emission. So which means the atoms in the excited state release to its lower state by emitting one photon after the lifetime. The lifetime must be in the order of 10 power minus 8 seconds. So here the atom in the excited state returns to the ground state by emitting a photon of energy h nu without the help of external radiation. This process is called spontaneous emission. Then stimulated emission. This is the very important phenomena for laser action. Here the excited electron or atom will relax to lower lying state, that is ground state, by emitting two photons. So here the two photons having high coherence and same direction and high intense to one. So here the atom in the excited state returns to the ground state by emitting two photon of energy h nu with the help of external radiation. So this process is called stimulated emission. So then, so there are some of the basic components which we need to construct the laser. So the main important components of laser are active medium, pumping source, and optical resonator. So first one is optical medium. This is a very important for achieving laser action. Here the medium in which the population inversion takes place is called active medium. Then the active medium can be either solid, liquid, or gas or semiconductor, etc. So then pumping source. Second one is pumping source. This is nothing but the source used to stimulate the atom or electron in the active media is called pumping source. So here the population inversion is achieved by pumping mechanisms such as optical pumping using flash lamps, then through gas, then through semiconductor junctions, etc. So third one is optical resonator. So it is a pair of reflecting mirrors. Here one mirror is 100% reflecting and another one is partially reflecting mirror. Here the active medium is kept in between these two mirrors. Then types of laser. Here some of the various types of lasers are given with the suitable examples. So first one is solid state laser. So example of solid state laser are ruby laser and Nd:YAG laser. Then gas laser. So the example of gas lasers are CO2 laser, argon laser and helium neon laser. Then liquid laser. The example of the liquid laser is europium lasers and SeO-Cl2 lasers. Then dye lasers, it consists of some Coherent dye lasers, etc. Then semiconductor lasers. This consists of gallium arsenide, then indium type of lasers. Then application of lasers. So we are all aware of applications of laser. We must come across the application of lasers in our everyday life. They are laser cutting, then laser welding, then laser eye treatment and skin treatment, etc. So here we are all come across by using these applications in our day-to-day life. So thank you. So we will discuss the working principles of type of laser in our next class. Thank you.